our topic for today is completing the square. We're going to start out by looking at something that we've already seen, which is a quadratic equation that we could solve. And I want to do this the way that we've already done it first. Okay? How would we solve this?
I did just split them up, like have like x.
Yeah, we would have something like x and x equals 0. And what would be my two factors of negative 8 that add up to negative 2?
4. Negative 4 and 2.
Negative 4 and a positive 2. So then I know that x minus 4 could equal 0.
Couldn't you also have positive 4 and negative 2? Because 4 minus 2 is... Oh, wait, never mind.
Okay.
So x
got it?
equals 4.
So x would equal 4, or x would equal negative 2. Now this is great. This is a really nice way of solving this equation. Right? If we were to graph this, if instead of we said equals 0, if we said equals y, we would end up with something sort of like this. We have a graph where the points where this crosses the line are 4 and negative 2. That's what we're doing here, right? When we're solving a quadratic, we're finding the points where it crosses the x-axis, negative 2 and 4. But there's something that's really kind of problematic about this. What if I had a parabola that crossed the x-axis like somewhere between negative 1 and negative 2? Like maybe it's like negative 1.235. How would I ever find the factor negative 1.235? I don't know any decimal factors. Right? I mean, technically there are infinite factors of 8. 8 is 4 times 2, it's 8 times 1, but it's also, 8 would be like, 8 divided by 1.75. We could find a factor of 1.75 and something. Right? I don't know what it would be. Are you doing it on your calculator?
4.5714285.
Yeah. Right? Whatever. So you would have to memorize every single possible factor of 8, which is impossible. There's no way you could ever know all the factors of a number because you could have decimal factors. So there is another way of solving these, and that's what I'm going to show you today. It's called completing the square. Let's remember the answer to this. The answer to this problem is 4 and negative 2. Now we're going to go through a different process to get that answer. So what I'm going to do here is I'm going to make this a perfect square. So remember, a perfect square is something like x plus 2 squared, or x minus 5 squared. And remember, when you expanded these, it's always like x squared plus 4x plus 4, or x squared minus 10x plus 25.
How is that?
Oh wait, can you
With
use
FOIL?
something, because you can also have like 2x plus 2 squared, right?
We could have a number in front of x. We're not going to get into that today. So the pattern here, right, is that this middle number is 2 times this, and this last number is this square. So I have to create a perfect square. And here's how you do it. We start with everything equaling 0, but then the first step is to actually get it so that we have no constant on this side. So I'm going to add 8 to both sides, but I'm going to leave a blank here. So this is really similar to what we did with converting standard form to vertex form. Step 1, it's going to sound really familiar. Step 1, we move the constant to the other So we sort of isolate the constant.
And the constant is.
The constant is the number that has no x, right? So 8. So I only have x's on this side.
Isn't that what you just undid though?
No, that's what I'm doing to get from here to here.
Oh.
I'm saying this is step 1. Yeah. So step 1 is doing this. Okay, step 2, I'm going to find half of this number. So what is half of negative 2? Negative 1.
Can we call that number B?
Yep. So step 2, find 1/2 of B. Technically this is not step 2, but for all the problems we're going to do today, this is step 2. The reason I say that is if I had an A, which we'll look at probably tomorrow or the next day, if I had something in front of x squared, I actually have to get rid of that first. But we're not going to worry about that for now. So find half of B, and then immediately I square that. So step 3, square that. What is negative 1 squared? Positive 1. And I add that to both sides of my equation. I can't just add 1 here, but I can add 1 to both sides of the equation. Right? That's allowed in algebra. I can add something to both sides of an equation. So I square this number and then add it to both sides. Let me make sure that all stayed on the video. It did. Half of b squared equals a positive 1. Okay, now I have a perfect square. I have completed the square. This, I'm going to rewrite it. This right here is a perfect square. Right? It's a perfect square trinomial, which is x minus 1 squared. X minus 1 squared. Because negative 1 times 2 is negative 2. Negative 1 times itself is 1. So step 4 is to factor that. Step 4 is you factor.
The perfect square?
You factor the side with x's.
Which just means doing from there to there.
That just means, yeah, from here to here. That's step 4. Okay? Here, you don't really have to do this. I just rewrote what I had up there, right? So now there's a different approach that we can now use to solving this than we've ever used before. Does anyone want to guess what we might do to solve this now?
Square both. Oh,
Okay, we could FOIL, but we just end up with that again.
Don't you do the thing where you have x minus 1 equals 9 and x minus 1 equals 9?
No. Because that was only true of 0, right?
Wouldn't it be x plus 1 and x?
No.
Oh, x equals 10. Square both.
Can I get rid of this square?
Yeah, if you square both.
Oh,
If I do what?
square root.
Yeah. I could now square root both sides. And that's kind of the whole reason that we do this. So if I square root both sides, that's step 5. Now I end up with something that I can solve. I'm going to use the symbol here. Square root both sides. There's a really important thing here, though, that happens. Okay? The square root of x minus 1 squared is x minus 1, no matter what. But what is the square root of 9?
3.
Okay, it is 3, or
Negative 3.
negative 3. So we write it like this, plus or minus 3.
How do you solve it then?
I'll show you.
Oh, do you have to?
2 answers, which we know we have 2 answers, right? We already know the answer to this. Okay, now I want to say something else here. The 3 could be a square root. I could end up with like x minus 1 equals plus or minus the square root of 5. And this will happen as you're solving them tonight. You'll end up with answers that have square roots in them.
That's okay.
Yeah. That's kind of,
But you could
that's
just
the
have
advantage of
plus 1
this
or
solution.
minus. Or like
Yeah.
plus, yeah.
So the next thing that I do, is because of that. I'm going to add 1 to both sides, but I'm going to add it in front of this plus or minus. So I'm going to add 1, and I have x equals 1 plus or minus 3.
How does that work?
So step 6, I isolate x by adding 1 in this case. I'm going to put a reminder over here. When we square root both sides, I'm going to say use plus or minus. So now, x is 1 plus 3 or minus 3. Wait, I thought the answer was 4 or negative 2.
Well,
But now I'm saying the answer is x equals 1 plus or minus 3.
Oh, but
it makes sense, but
well,
how do
see,
you write it that
3
way? It just doesn't. 3 plus 1 is 4, and then 3
Oh.
minus 2.
I'm not done, right? X equals 1 plus or minus 3. Well, I know what 1 plus or minus 3 is. 1 plus 3 is 4.
So much harder.
Or 1 minus 3 is negative 2. So I got the same answers, right? 4 or negative 2. But yeah, this is so much harder. So why do we use it? We use it because not everything can be factored. So now we're going to do a problem where you wouldn't be able to solve it with factoring. Okay? So this is going to seem a little weird.
Is that the answer?
That's your answer, yeah. I'm going to keep those steps up there. And now we're going to do this one. So if I had this, x squared plus 13x
Are we doing another problem?
plus 15. Okay, equals 0. So we could sit here thinking factors of 15 that add up to 13,
5 and 3.
they don't exist.
No, they're
There are
probably
none.
decimals.
Yeah, they are decimals. They do exist as decimals. So you can't solve this by factoring. We'd be here all day. So we're going to use completing the square. Step 1, move the constant to the other side. What do I do? Subtract 15 from both sides. What do I end up with?
X squared plus 13x blank equals negative 15 blank.
Okay.
Point blank.
Step 2, find half of b.
Oh, half of 13, isn't that like
7.
Now, I'll give you a hint. It's easier to just keep it as a fraction.
13 over 2?
13 over 2. Okay? Square this. What is 13 over 2 squared? Well, it's 13 squared over 2 squared, which is 169 over 4. So step 3 still, I add that to both sides. Okay, I'm going to rewrite it again, just because I think it's clearer for the video. So x squared plus 13x plus 169 over 4 equals, now I want to turn this into fourths.
What?
Because I have to combine negative 15 and 169 over
Oh,
4.
it doesn't.
So negative 15 is negative 60 fourths.
What?
Yeah, how do you know that?
Because I know 15 times 4. 15 times 4 is 60.
Why do you know that?
Well, I mean, I don't know if I know it. 15 times 2 is 30. So 15 times 4 is 60, right? So I'm just taking negative 15 times 4 over 4, which is times 1. I'm just converting this number into an improper fraction. Okay? So now I could combine these like terms, which I'll do in the next step. But step 4 says factor the side with x. How do I factor this? It's a perfect square though.
Oh.
Remember this number that we found?
Oh, so
It's pretty simple actually. What is it?
x squared, or no, not x squared. X what? Minus, no, plus, minus, yes, no, plus. X plus 13 over.
Yeah. X plus 13 over 2. That's it.
Wait, Nate, is it always going to be a positive right there?
No, it was because I mean, if you multiply
No, it could be a negative or a
It
positive.
was a negative in the last. Wait, but isn't it like? Oh, well, I mean, the things that you put in the blanks can't be negative, right? Because if you
Right.
multiply negative-
This will always be a positive because I'm squaring something, and the square of something is always a positive. Okay, equals, I'm going to combine these two fractions. So negative 60 and 169 is actually 109 over 4.
That's a 13. 13 though.
13's right there.
But how?
Well, I factored this into this. This equals this. If I FOILed this out, right? X plus 13 halves times x plus 13 halves, I would get x squared, that's that. I would get 13 halves x plus 13 halves x, which is 13x. And then I would get 13 halves times 13 halves, which is 169. This equals that, right? That's what factoring is. It's just making something that's equal, but in a different form. But it's really easy to factor these because we already found the number that has to go there, right? When I do step 2, I can use that number in here when I factor. Okay? So this step is actually really easy. Factoring is really easy because you just simply look right here and you say, oh, x plus that squared. That's all you ever have to do. Now step 5 says square root both sides. Remember to use plus or minus. What do I get when I square root both sides?
13 over 2.
And now I'm just going to do it like this. So I'm going to, let me think. Let me show you over here.
Why
So
is it
I have this, right? The square root of 109 over 4.
It's the square root of 109.
That's the same thing as the square root of 109 over the square root of 4. Do you guys agree?
Yeah.
Do you know that rule? These are the same. But I also have to remember that plus or minus. I'm always going to put the plus or minus in the top. So I'm going to write it like this. Plus or minus the square root of 109 over the square root of 4. The square root of 4, though, is 2. So it's over 2. Yeah.
Why when you square it, do you get 13 over 2 again?
Because I'm squaring this whole side. I mean, I'm square rooting this whole side. So all that I'm doing is getting rid of the square. The square root of something squared
Oh, you're square
is just
rooting
that
it.
something. Yeah. I probably should write that out. Right? Square rooting gives us this. Okay, now how do I isolate x?
Subtract 13.
Subtract 13 halves. And remember, I'm going to write that in front of my other fraction. Now, this usually happens. I have the same denominator.
Why is it negative?
2 and 2. Well, I have x plus 13 halves, so I want to subtract the 13 halves to get rid of it. I'm trying to isolate x.
Right.
So I've got x equals, I'm going to write this first, negative 13 halves. And then I have plus or minus square root of 109 over 2.
Is that your answer?
I'm really close because there's nothing I can really do with the square root of 109. But
It's 10.
I do have both fractions with the same denominator, So I can combine those, right? I can combine this to be negative 13 plus or minus the square root of 109 all over 2. And that's my answer, right? X equals that. A piece of this, guys, is just noticing these patterns, right? If I remember to write the negative 13 halves in front of the other fraction, if I remember to write the plus or minus in front of the square root, and then things just kind of will line up, a lot of your answers will look like this. Okay? A lot of your answers will look like a number plus or minus a square root over a number. Now, sometimes you won't have a denominator. Like sometimes if I had, 108 over 4 here, I would have been able to simplify 108 over 4. Yeah. But factoring would be so hard. I mean, how many of you would have realized that the factors of 15 that add up to 13? Oh yeah, I mean, come on guys, it's just like plus 13 plus or minus the square root of 109 over 2, and then it's just like, so that would be minus.
Wait, wasn't that a minus 13 though, Nate?
And it would just be like minus
Minus
that.
13.
Well, it's actually, we'd have to then get rid of this, so it would be that, and then it would be minus with a minus.
Well, Nate.
But how many of you would have thought of that, right?
Oh.
Never, and I probably even did that wrong. I don't even know if that's correct. It's, I mean, it's
if you
so,
look at this, it looks like gibberish.
it looks so weird, right?
All of this looks like gibberish. Like
Now, we could take a calculator, and we could do in a calculator negative 13 plus the square root of 109, and then divide that by 2.
The square root of 109 is 10.440306.
So what would be your final answer then?
yeah.
So if we had 13, negative 13 plus
It's
10 or whatever, divided by 2, I think we would get negative 1.279.
It's I think this calculator did it wrong.
And then the other one should be negative 11.72.
Wait, it's negative.
We can just leave the answer like that, though.
You can leave the answer like this, that's fine with me.
It's negative. What is it? Negative 13 plus.
And then you have to do the square root of 109.
root of 109.
That won't work in that calculator though, because it's not a scientific calculator. So if you want to use one of these calculators, this is not really important, but
Nate, can you
if you want to use one of these calculators,
It's like 69.
right, to do this, you would have to do this first. You'd have to say 109 square root, and then I could say plus negative 13 plus 13 negative, and then divide that by 2, and I get 1.27984675. Or I could do the same thing and I would get that.
Nate,
All right, guys.
honestly,